We'll proceed in tedious calculus problem. Tedious calculus problem, rather than we can say something like real life calculus. How we can use real life calculus, that is the discussion that we are pursuing. Anyway, we what we had very far. Okay, so what we had till now is kind of I don't know. Okay, so we have the circuit, so I believe it is visible, and this is battery, and this is capacitor, and here there is one resistor in between, and then two LED I have connected so that it will be prominent. I don't know how much this battery is charged, but this is how it is. I have another battery also, and then I have one more. I have taken one more kind of this is a 330 microfarad capacitor, and this is a 330 ohm resistor. I believe it should be visible. This is the resistor. This is soldering. So, and this is the capacitor. Okay, so this is the real life example. So if I charge this, so I don't know this battery is how much it is. So we were discussing about the discharge circuit. So I am going to charge it, and this is positive. So it will connect to positive, and I'll connect it to negative. Oh. I don't know how much it will charge. Okay, and I'll connect. So I'll charge directly so that it will charge quickly. So I have connected now positive and negative of the capacitor to this battery, and let's see, it will charge to some extent. Okay, so directly I connected, so it will be charged. Now I believe it is charged. If it is charged, then I'm going to place this RC. This is RC, resistance and capacitance, across a diode. This is the diode, across the diode, and across the LED, that is diode only, and then it should kind of discharge slowly. So it will give a blink, it will give a light, and slowly it will discharge. Probably this is the only thing we'll show. I have not tried it. Okay, now this is visible. I'm going to place it. Not, oh, wow. Okay, now gone. So there was a light, and slowly it became dim. Okay, I can recharge it. So this is positive, and this is negative. I can tie it, and I'll keep it for some time. Okay, so I have given it to charge. I believe polarity is all right, and it is charging now. Okay, it is charging now. For some time it will charge, and then I am going to disconnect it. Now this is capacitor 330 microfarad, and there is a resistor here 330 ohm. Now this RC circuit, this capacitor is completely charged. Okay, then I'm going to place again, then I'll charge again one more time and I'll place again the multimeter. Now I have placed across the one side of the LED. This is LED, white color. Now I'll place it and it will blink and it will go down. Okay, I did twice. That is the mistake I did. So it blinked. Immediately it will grow very high and slowly it will come down. Okay, I'll charge once more. I should have soldered it. That's the mistake I did. Okay, I'm charging it again. Okay, it is charging now. So I am charging again with the battery and then I'll try to see it is going away on the kind of multimeter. So this is charging directly with the battery. Now this capacitor is completely charged. Now I'll place again the multimeter and I'll see the reading with RC circuit. Multimeter should constantly show that reading is going down. Okay, we have many interesting things. Don't go away. Okay, so this is positive. Okay, so I'll put it into a voltage mode and it is now in voltage mode. Okay, negative I am going to put in the negative side of the RC circuit and positive to the positive side. So I'll tie it so that I did not carry it. Okay, negative side I have tied it and positive side I am going to tie it. Okay, now this is the multimeter and it is I'm sure it is showing around zero point 0.1. Okay, actually it is. I'll restart it. Okay, there is nothing connected and it is more or less it is zero. Okay, this is zero. If it is zero, very minimal is there. Now I am going to connect a kind of to RC circuit. This is the capacitor is charged and through RC I'm going to connect it. Now it is showing 3.3 point, no, it is decreasing. Now through register it is 3.58, 57, 56, 54, 53, 51, 50. Okay, so this capacitor is discharging through this register and 3.1, how much it is? 3.08. It is going down. If it comes in 2, I'll close it. 3.03, 3, 2 point. So this is called RC circuit. Now capacitor is discharging. I have connected through a resistor and then connected to this voltmeter. And then voltage is a kind of dropping for the RC circuit completely. So this is discharging. Okay, so this is the scenario of the RC, but I have connected this multimeter across this voltage multimeter across the resistor and capacitor. Okay, 2.78, 2.72. So this is through resistor, the capacitor is discharging. Okay, this is called RC circuit where it is keep on discharging. 2.65, slowly it will come to 0. Okay, this is how it is discharging. Okay, if I want fast discharge, then I can place it across the LED and it will do the discharge quickly. Okay, so this is Mr. LED and I'll try discharging it quickly. So this is one side of LED and I believe LED, white color LED is visible. I'll touch it and it will grow. Okay, at the beginning, bright LED was glowing and slowly it came down. Now this is the discharge circuit. In past video, we were talking about discharge calculus. Okay, experiment is over. Now the concept is that how we can do this, how can we can calculate this through calculus. Why we need calculus? The inherent nature of capacitor leads us to go with the calculus. Does resistor need calculus? Okay, the idea here we have a 330 ohm resistor and to the series of resistor we have connected a 330 ohm resistor. Okay, this is 330 ohm resistor and to the series of this we have connected 330 microfarad capacitor. These are the two ends of the RC circuit. If I connect this two end to a battery, then this capacitor will start charging. Whereas if I connect these two end together, then capacitor will start discharging through the resistor. So that is the concept of RC circuit. Very nice it is. Now idea is that what are the things that we are seeing difference between resistor and capacitor. Resistor is considered as a linear resistor. Means resistance of the resistor is always constant, is never varies. Whereas resistance of the resistor, it is constant, it never changes. If I say it is 330 ohm, then it is always 330 ohm. Okay, what about capacitor? There is something called capacitance, like it is 330 microfarad capacitance. Then capacitance will not change. Electronics is a game of resistance. Electronics is not game of capacitance. Electronics is not game of voltage. Electronics is not game of current. Electronics is a game of resistance. Okay, sometimes we specify voltage and current in the term of complex numbers also. So where many things we do when we try to model it into mathematics. Okay, if it is a game of resistance, then what is the resistance of this capacitor? Can we calculate it? Anyway, if this capacitor is charged at a voltage that is called Vs, if this capacitor is charged into voltage called Vs, and then I'm applying this capacitance across the resistor. Capacitor is behaving like a battery, and then through resistor current is flowing. The beginning current will be very high, and because there is a lot of charge that is stored at the capacitor plates. As we connect this capacitor to a resistor, this charge will start becoming current. The charge will start becoming a current. Okay, you can consider like a cotton. There is a cotton, I don't know what it is called. In household, people generate thread out of the cotton. People generate thread out of the cotton. And if you keep the cotton and if you are generating the thread, slowly cotton will melt and it will become thread. And after some time, there won't be any cotton and full cotton will become thread. Similarly, if there is a charge on the capacitor, then it will become current that will flow. Slowly charge will diminish and it will converted into current. One time will come, there is no charge at all. Full charge is converted into current and Mr. Resistor has spent all the current. It dissipated all the current. So that is the concept. Now, if this is a scenario, what would be the equation of the current at any time? At the beginning, if Vs is the voltage of a capacitor, if this is the capacitor, this is the resistor, and this is the capacitor. If I connect this capacitor across the resistor, if I connect this capacitor across the resistor, Okay, then we have positive and negative side of the capacitor. Is it connected to a resistor? Now current will flow. Okay, the voltage across capacitor is same as voltage across resistor is same as voltage across capacitor because they are connected in a kind of series or parallel, whatever comes to someone's mind, he can say. In that sense, voltage at the capacitor at any moment is how much is the capacitor charge it is carrying. Charge divided by the capacitance. Charge at the capacitor plate divided by the capacitance. That is the voltage at that moment. If charge is low, then voltage is low. Charge is high, then voltage is high. If this capacitor is completely charged, then it is holding maximum charge it can hold. If I increase the capacitance, making the same charge, if there is a charge, I still don't have I believe Faraday or something is there, which is the which I don't remember, which is the symbol of the which is the kind of notation for the charge. So if I have a Q charge that is stored at capacitor and I increase the capacitance, then voltage will be less. Anyone can try. Okay, keep the capacitor charge constant and increase the capacitance of the capacitor. How to increase capacitance of capacitor? I really don't know. Okay, one way to it is take this capacitor and another capacitor with different capacitance and connect it. Then full charge of this will go to that capacitor. It will come to some kind of in between, whatever it is. Now calculate the charge at other capacitor, or try to do something that another capacitor with different capacitance is carrying same charge, or same capacitor increase the capacitance keeping the same charge across the plate. Capacitor is built like there is a two plate, cathode plate, anode plate, and charge is stored at the plate, making the potential difference. If charge is same and you are increasing the capacitance of the capacitor, probably plate size will grow or plate thickness will grow, plate material will grow. In between, whatever cushion is there, chemical is there, that will change. Capacitance will change. If capacitance is growing, keeping the charge constant, then voltage will decrease. If capacitance is decreasing, keeping the charge constant, voltage will increase, whatever it is. So voltage at any moment is charged by capacitor because it is inversely proportional to capacitance and directly proportional to the charge. So that voltage at any moment across the capacitor in RC discharge circuit is same as the current that is flowing through the resistor into the resistance. That is the voltage drop there. I into R equal to Q by C, or R into di by dt equal to 1 by C dq by dt. I did not take division because differentiation also covers division. Numerical division is covered by differentiation, whereas differentiation is not covered by numerical division. We have talked about it. If I have a function that is x square that is dependent upon another variable x, then x square by x is not x, it is 2x. That is the actual division. If we are dividing two variables and numerator is dependent upon denominator, they are not independent to each other. In that sense, division will not give the accurate result. What accurate? It will give some vague result. Differentiation, calculus differentiation will give the actual division. Now, in that sense, if I am saying 1 by C into Q is voltage and I into R is the voltage across the resistor, then if I say dq by dt, if I say q by t, if I divide both sides by time, because voltage is dependent upon the time. Voltage is dependent upon the time across the capacitor. If I move in the time, voltage across the capacitor in RC discharge circuit will go down. Okay, because it's discharging through resistor. So I can place on the denominator time per unit of the time in 1 second how much change in the charge I am seeing. That is by t. So 1 by c into q by t equal to r into I by t. Okay, but problem is charge. The change in the charge I am seeing per unit time. Per unit time if time is 4 seconds, when I connected this capacitor across this register, then I started the stopwatch. When time is 4 seconds, then 4 seconds to 5 seconds in 1 unit of time. Unit of time may not be 1 second, it can be 1 millisecond, 1 microsecond, 1 nanosecond, 1 picosecond also. Depend upon how much what people want. So if I am taking 1 second as a unit of time, if time on the stopwatch is 4 seconds, between 4 seconds to 5 seconds, what is the change in the charge I am seeing? That is called division. Division means at any moment consider charge is Q1 and at time is 4 seconds. Now 4 seconds to 5 seconds, 1 second difference I am seeing, then charge is Q2. New charge is Qt at the plate. Q2 Q2 minus Q1 divided by T2 minus T1. That is called division. How much is the change in the charge I am seeing when there is 1 unit of time is there, but time is 4 to 5, whatever, 1 unit. If I see between 10 second to 11 second, again time is 1 second only. And at 10 second, measure the charge, at 11 second, measure the charge. With 1 second of the time difference, how many charge difference is there? If it is same, every 1 second difference in the charge is same, then division will work. Q by T will work. Okay, Q by T, change in the charge per unit time is called current. Like change in the cotton per unit second is called thread. Make sense? If the cotton I am using to make thread, if cotton is this big and next second it is this small, then thread amount will be very high because change in the cotton per second is very high. Similarly, if change in the charge per second of the time is high, then current that is generated from this charge is high. But if any moment of the time, if I take 1 second and difference in the charge is same, then division will work. If it is not same, means from the first second to second second, that is 1 second time period, if I see the change in the charge, and then third second to fourth second, 1 second time period, if I see the change in the charge, then 8 second to 9 second, 1 second time period, if I see the change in the charge, all three charge differences are same, means charge difference is dependent upon the time at which we are calculating the difference in the charge per unit second. If between 1 second to 2 seconds, if it change in the charge amount is 2, and between 3 seconds and 4 seconds, the change in the charge amount is 0.5. Between 10 seconds to 11 seconds, change in the charge is 0.1. Means every second, in every time moment, if I take 1 second, change in the charge is not same. If that is the case, then change in the charge is dependent upon, because everywhere we are taking 1 unit of time only. Means change in the charge is dependent upon the time at which we are calculating this this mathematics. When we are calculating this calculation, we are making this empirical. We are collecting empirical data. Change in the charge is dependent upon the time at which we are calculating it. So in that sense, Q by T, Q Q by T means change in the charge per unit of time. But that change in the charge is dependent upon T. Every moment of T, if I take 1 unit of time, change in the charge is different. If that is the case, then it is candidate for calculus. This is the aim of this discussion, where we use division and where we use differentiation. Differentiation is we use when numerator is dependent upon denominator. If I say Q by T, every moment of the time, if I take 1 unit of time, change in Q is same, irrespective of at what moment we are calculating change in the charge per unit change in the time. If that is the case, then division will work. And for the resistance, we don't need calculus. If I have a battery and resistance is there, what is the current? That is volt by resistance. If voltage is not changing, resistance is not changing, current will not change. I equal to V by R. If you see the volt, there is a battery and there is a resistor. Okay, what is the current? When I switch it on, current will start flowing through the resistor. What is the current? Current equal to voltage by R. What is the current at any time? dV by dR. Not true, not required. dV by dR, if I say, that is also okay. Division is subset of differentiation. If I take division, differentiation, it will cover division also. Current equal to V by R. In none of the book you will see current across a resistor is dV by dR, because the change in the V by R means change in the voltage per unit change in the current in the resistance. Both are constant. No one is changing. In that sense, numerator is not dependent upon denominator. In that sense, we don't need calculus at all. I equal to V by R. Okay, but here we have voltage equal to Q by C. If I talk in the current, then V by T equal to Q into equal to 1 by C into Q by T. That is wrong. Q by T is wrong because Q is dependent upon T. We are trying to calculate change in Q with that 1 unit change in time, and then Q by T, since Q is dependent upon T, V by T equal to change in the voltage per unit change in the time. Voltage across the capacitor is decreasing. If I have charged the capacitor completely and then I have put a resistor across it, then voltage will start decreasing because charge will change its shape into current, and current will be dissipated by the resistor. In that sense, voltage will decrease. At any 1 unit of change in time, how much change in the voltage I am seeing? It is decreasing. So V by T is change in voltage per unit change in time equal to 1 by C into Q by T. That is same as 1 by C change in the charge divide change in the charge we see per unit change in the time. But this is wrong, because division will not work here, because voltage is dependent upon time. Whatever change in voltage we are seeing, that change in the voltage is dependent upon at what time we are calculating change in the voltage per unit change in the time. So it is dV by dt, not V by T. dV by dt equal to 1 by C dQ by dt. This is the better notation. Anyway, now we know that voltage across capacitor in the RC discharge circuit is same as voltage across resistor. In that sense, voltage across capacitor is 1 by C Q equal to I into R. That is same as 1 by C dQ by dt equal to R di by dt, because current will change. At the beginning, current will be high, slowly current will change. Current is again function over T. Current is dependent upon T. Now it becomes dq by dt is current. I know this. So 1 by C into I equal to R into I. But problem is charge. There are two modes of capacitance. One mode is charging capacitor when charge is growing. When charge is growing, dq by dt, the change in the q per unit change in the time is positive. Means charge is growing. dq by dt is negative when it is discharging. The change in the q1 to qt at any time 3 seconds, the charge of the capacitor is q1. At the time of 4 seconds, charge at the capacitor is q2. q2 minus q1 is negative. So dq by dt is negative. So we have minus I. So we have 1 by C minus I equal to R into di by dt. Now if someone settle it down, then it become minus dt by RC equal to di by I. Then di by I integration is natural log ln I from lower limit to higher limit. Lower limit, lower limit of this calculation is when we started this calculation. So at the beginning, the current is I0. Okay, from there we started the calculation. And now current is I. If this is the graph, this is the time, and this is the current, at the beginning current will be high and current will slowly go down. So beginning at the time equal to 0, what is the current? That is I0, the maximum current. And then at any moment of the time, current is I. Ln I by I0 equal to dt, that is integration is t 0 to t minus t by RC. Someone settle down I equal to I0 e to the power minus t by RC. I0 is the initial voltage of the capacitor, that is Vs. Vs by R. So I equal to Vs by R e to the power minus t by Rc. This is the equation that we are deriving. Okay, that you told in last video also. Okay, what is the concept behind your resistance? You talked about resistance, right? Okay, I talked about resistance. Electronics is game of resistance. OpenGL 3D modeling is game of vertices, not the full shape. If I'll okay, can you draw this? Can you draw this on computer screen? Okay, the way it is, can you draw this on computer screen? I don't need complete thing, complete shape. Few vertices I'll take, and through that I will estimate the shape of this, and then I'll estimate the color and I'll draw it. So 3D graphics is a game of vertices. Okay, like machine learning is game of features. What are the orthogonal features are? Anyway, Cartesian code the mathematics. If I see the dimensionality, then it is game of orthogonal component. Similarly, electronics is game of resistance. If I have RC circuit. If I have a charging circuit, oh, where it went? If I have a charging circuit, okay, so this is capacitor and this is resistor. It is connected to a battery. Consider it is connected to a battery. This is a capacitor and this is resistor. It is connected to a battery. Okay, when it is connected to a battery, as per the Kirchhoff's theorem, then in a loop, the net voltage will be zero. Means net battery voltage is same as voltage across the capacitor and voltage across the resistor. If I shunt this, then battery equal to zero. Battery equal to zero. Earlier, Vs, that was the battery source. Vs equal to voltage across capacitor, that is V, plus I into R. If Vs is zero, then voltage across capacitor equal to minus I into R. Someone can get from this concept also. But best concept is that what is if battery is not there at all? The way I did, I charge it through a battery and take it out and then connect like this. Anyway, if I have considered, now this is RC circuit, this is a discharging circuit. Now, if I talk about resistance, then what is the resistance of capacitor? Can someone connect? Can someone kind of talk in that fashion? What is the resistance of the capacitor? Consider resistance of the capacitance. Any moment is R, small r, whereas the resistance of resistor is capital R. Now, any moment the current through capacitor in discharging circuit is I0, that is voltage, the beginning voltage of the capacitor by capital R, that is the I0, into e to the power minus t by RC, capital RC. This is the formula. Okay, if this is the formula, then what is the resistance across the capacitor? Or someone can think about it. Can we draw a resistance model of the capacitor RC circuit in charging mode and discharging mode? Consider at any moment. Okay. The big thing that we are going to talk about, the resistance of a resistor is constant. Resistance of a resistor is constant. Okay, voltage across this capacitor is variable. That is for true. That is for sure. And current, if I put in RC circuit, then current that is flowing in this circuit also variable. If voltage by current is constant, the voltage across the plate of the capacitor in RC circuit divided by current that is flowing through the plate. If voltage by current is that relationship is constant, then resistance is constant. What is the resistance of a capacitor? Any capacitor, anyone would ask this question. What is the capacitor formula? Voltage equal to charge by capacitance. dV by dt, dV by dt equal to I by C. dV by dt equal to I by C. Okay, that is the formula. So what about the resistance of capacitor? I don't know. What is resistance of capacitor? But one thing for sure, at any moment, what is the voltage across the capacitor? Divide it by the how much current is flowing through the capacitor. Like if I know the voltage across a resistor and how much is the current that is flowing through the resistor, If I divide voltage by current, that is the resistor's resistance. If voltage is decreasing around the resistor, then current will decrease in same fashion so that V by R is always constant. That is the resistor's resistance. Is it the same for the capacitor? I don't know. Can someone draw can someone write a formula where resistance of the capacitor will have formula, we have voltage and current relationship. Resistance of a resistor R equal to voltage by current. If voltage is decreasing in RC circuit, current will decrease in same fashion so that V by R across a resistor is always constant. Is it same for capacitor? If in RC discharging circuit, voltage across the capacitor and current that is passing through the plate, if I divide V by I, is it the same? One thing is for sure that charge by voltage, the net charge the capacitor is carrying, slowly charge is going low in RC discharge circuit. But still, whatever the charge the capacitor is carrying, divide it by voltage will be the capacitance. Capacitance equal to net charge that hold by the plate, divide it by the voltage, how much it is carrying. If charge is decreasing, voltage will decrease. If charge is increasing, voltage will increase. But this division will always be constant, Q by V, and that is capacitance. Whereas the resistance of the capacitor is voltage by current, and I don't know it is constant or not. If it is constant, then resistance of capacitor is it constant. If it is not constant, then what it is? Okay, can someone take it as a kind of assignment that what it is? Okay, in one thing for sure, we know that voltage across capacitor, current across capacitor, at any moment, current across capacitor in RC discharge circuit, any moment is the initial current, that is the initial voltage divided by the resistance of the resistor, Vs by R, or initial current I0 e to the power minus t by RC. If there is any resistance in the capacitor at any moment and that resistance is R, consider it is variable, then I into R is the voltage at that time. So voltage at that time is I0 into small r, that is the resistance at that time. R into I0 e to the power minus t by capital RC is the voltage at that time, and that is equal to voltage across the capacitor, that is Q by C. Q by C equal to variable resistance. Consider it is variable. Consider variable resistance at the of the capacitor. Q by C equal to R I0 e to the power minus t by RC. I0 is constant, that is for sure. R is variable, whatever. R is variable. E to the power minus t by RC is variable, where R and C are fixed. T is varying. Okay, what is R? R, that is capacitance resistance. R, this is not available in any of the book, that how to calculate resistance of the capacitor at any moment. R equal to, this is called actual electronic model. Then R equal to Q by C. Q by C into 1 by I0 e to the power minus t by RC. R equal to Q by C into 1 by I0 into e to the power t by RC minus t, above it will go, it becomes t by RC. Now we have resistance formula as a function of time. Hop. R equal to Q by C. R equal to Q by C into 1 by I0 into e to the power t by RC, where R is resistance of the resistor. Now Q I can replace as integration of I dt, or dq by dt I can replace with di. What is the change in resistance? We see per unit change in the time. Since resistance I have considered it as a variable, dr by dt, resistance small r, the resistance of the capacitor, dr by dt equal to equal to Q by C into 1 by I0. C and I0. I0, Q, C and I believe, or I did something wrong. Okay, the initial idea was, okay, I believe it is all right. Q by C, dr by dt equal to d by dt of whole term Q by C into 1 by I0 into e to the power t by RC. Okay, C and I0 will come out, they are constant. Now Q is variable and t is variable by dt. Now we can use rule of multiplication. So it will become e to the power t by RC into dq by dt plus q into e to the power t by RC into 1 by RC, that is dr by dt. Can we proceed on this in the term of real calculation of R, not dr by dt? Okay, okay, many things more we will talk about RC circuit. This is not a tedious calculus problem, this is real life calculus problem. How we proceed in so many models in RC circuit. We will proceed on this. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.